Hello everyone, this video will talk about an example question on concentration cell. Okay, so now let's start reading this question. Okay, so this question says is asked us to calculate cell potential. Okay, and then given us cell notation and then the temperature. That's it. Okay, so that's all we have. And now let's think about what we're gonna do. Okay, so as first thing first, right? Since I said we are looking into a concentration cell, but then just say a random question, how do we recognize as a concentration cell? Okay, so concentration cell basically you can recognize it by knowing that that the cell itself will have the same electrode, same electrolyte on both anode and cathode side. You go, which side is anode? As I said, the cell notation itself, we know from left to right, is anode to cathode expression by convention. Okay, so the double line in the middle that represents cell bridge. Okay, so this is our cell. Okay, so then as I said, okay, anode, I have my oxidation half, and then let's try to write that. Okay, so my oxidation half fraction. Okay, then I have iron. Since oxidation number increase, it will turn into iron 3 plus, iron 3 ion, and then produce or lost 3 moles of electron. Okay, and then my reduction half fraction, I will have my oxidation number decrease, so it goes from iron ion, gaining 3 moles of electrons and turn it back into iron solid. Okay, so that's my half fractions. Then you go, okay, so now what? Okay, so now you go, I'm looking for E cell. Again, we also another characteristic, right? So being a concentration cell, as I said, everything is the same except what's different is the concentrations of the electrons are different. And then because of that difference, and then there will be having the electron flows. Okay, so that's what that is. And then apparently, right? So the concentrations are not 1 molar, so which means we are calculating this is a non-standard condition. Okay, and then go if it's a non-standard condition, what, oh, I know which equation I'm supposed to use. E cell or equals to E naught cell minus 0.0592 divide number of moles of electrons involved in this redox reaction log of Q. Q represents quotient. Okay, so this is equation supposed to use, and then you go, okay, let's see how we don't have E naught cell. We can figure out the moles of electrons involved in this redox reaction. Q, we can calculate it, right? Okay, so then you go, okay, so then that's not bad, but then let's think about what about this E naught cell? You go, maybe there's some information missing here. I don't have it. How I'm gonna calculate it? Okay, I don't have any standard reduction half fraction, the value for the iron. Okay, so then you go, okay, if I'm about to go to the table to find it, remember that table listed are all standard reduction half fractions. And as we know, in order to calculate E naught cell, I'm going to actually write it over here. Okay, so the E naught cell should equals to E naught of the cathode minus E naught of the anode. Okay, and then again, all the values for the reduction half fraction happens at cathode and oxidation half fraction happens at anode. All the values we will use will be the reduction. Remember the standard reduction half fractions. Okay, so then therefore, then when we go look for it, we have to do this, right? We have to actually put my oxidation half into its reduction half minor. Then I can actually look for the value. Okay, so this is why I need to redo it. Then go, oh, that's the same, right? If they're the same, we know what's going to happen. The value will be the same if they have the same value, right? The E naught cell for concentration cell, they're just 0. You go, now that's so great to know because now just made everything so much easier, right? So for a concentration cell, now we know in a cell for that is going to be 0. Again, because the standard reduction half fractions for both will be the same because we have the same electrolytes and electrodes, right? Okay, so that's for that part. And now, really, we need to calculate is that the number of moles of electrons. Okay, for this reaction, then we know again, right, 3 moles of electrons. So that's 3 log of Q. Okay, so your Q should be products over reactants. Okay, so then you go, what should be my overall reaction? Since it's the same, but remember still, right? So still is that you have to know this is how it's supposed to do it. Okay, so I'm gonna turn my reaction back. So I'm gonna show you one more time how you can go from cell notation and then go to half fractions, then therefore go back to the overall reaction. Okay, so this is my original half fraction, right? Okay, so that's my oxidation half. Okay, so when you add these two equations up, okay, so that's how it's supposed to be, right? So let me get some space. Let's do that. Okay, so I'm gonna have my iron, right? I'll use the purple. Purple is from a reduction half, right? So let's actually highlight the concentration, right? The purple was this one, 2.33. That's my reduction half. So that's the concentration. 3 moles, we know that will be canceled out because, right, the number of moles of electrons involved in the redox reaction will be the same, right? Okay, so that's for that. And then you have iron. This blue one, the blue concentration that's on my oxidation half, so that will be 0.0011. 2 zeros, 1 molar. Okay, and then what else I have? Then I have this iron solid. Okay, so then you go, that's supposed to be canceling out, but still you have to realize, right, the concentrations are different. I will have a Q. Okay, so that Q, now you see which one is your product, right? So the iron is from the oxidation half. This will be as the product. Okay, and then this. Okay, so now let's plug it in. Product 0.0011 divided by 2.33. Okay, so that's what we have, and that's your Q. Do the calculation, then we can calculate the E cell. Okay, E cell will equals to positive 0.066 volts. Okay, so that will be the answer for this question. Okay, so A will be our choice. Again, the important part is you know how to read from the cell notation and figure out this should be 0 and how many moles of electrons and then how to calculate Q. Okay, so this Q come from you understand. Okay, so just readjust on as a shortcut, right? Okay, so since this will be the product, right? That will be the product. Look, that will be the product for your oxidation half. So as overall, that will be your product as well, the blue one. Right? Okay, so that's blue one. This is going to be part of your product. Okay, and then this electrolyte on the reduction half, that's going to be part of the reactant. Okay, so then now if you're clear about that, that Q now should be very easy, right? So you go products over reactants, then you're good. Okay, so that's all about this question. This is concentration cell, and then thank you for listening, and hopefully this is helpful.